So we're going to try to work through the same idea. Yeah. We're going to do square roots and cube roots at the same time. Not because they're the same thing. They're obviously slightly related. But because we start seeing that we're using this pattern. It doesn't matter what the function is. We make a parent function that has a specific table with it, and then we just do these transformations to that table and are able to then move forward. So for our square root function, we want to get an idea of what the parent function looks like. Now, in our quadratic and our cubic, we've used 0 and then -1 and -2, +1 and +2 to build the parent function table. It's going to be a little bit different here, part because the function is undefined for certain values, and part because I just want to plug in numbers that are easy for me to calculate. When you square things, I can square anything, okay? And pretty much if you plugged in an integer until they get really big, I can tell you what the answer is. What are the restrictions on the square root? What would we not be able to plug into this function? Sophia? Yeah, good. So negative values. So first of all, the negative values are out. I understand we could use I to express them, but we can't graph that on a real number system coordinate plane. So that's not going to help me. So 0 is going to be like my beginning value. I'm not going to plug in anything below 0. So I want to get at least 3 points. I want to plug in 0. And then I'm going to be picky about what I choose. I'm going to choose things that I can get the answer to without a calculator. So I want to choose things that I know the square root of. So usually after 0, we would plug in 1. Do we still want to plug in 1? Do you know the square root of 1? Yes. What the square root of 1 is? 1. So I do want to plug in 1 because it seems like an okay value to plug in. Okay. Do I want to plug in 2? No. Okay. And it's not that there isn't a square root of 2. There is something a little bit more than 1, but I don't know its exact value, and it would be difficult for me to graph that. So what is the next nice number that I would want to plug in? Abby? 4. Good. Okay, perfect squares, right? And then beyond that, 9, and then I don't really want, 16. We could keep going, but then eventually we're going to be so far off the graph, we're not going to get good numbers. So does everybody understand why we don't have like a -2, -1, 0, 1, and 2 right here? Okay. I chose differently, partially because negatives can't be plugged in here, so that got rid of all the negatives. And then I didn't want to just go in order 0, 1, 2, because 2 is something hard for me to plot, and so would 3 be, but 4 is rather nice. So I kind of was picky and just picked and chose the numbers that would work well in a square root. So then I'm going to go ahead and make the chart for this function, meaning plug in each of these as an x and see what the y would be for it. So the square root of 0 would be 0. The square root of 1 would be 1. The square root of 4 would be 2, and the square root of 9 would be 3. So 0, 0, 1, 1, 4, 2, and then 9, 3. So this is the graph that I'm getting. And notice, unlike a lot of the other graphs, it does not keep going over here. Okay, it kind of has this end point because we're not able to plug in negatives. So our h and our k, what are our h and our k for this function? 0, 0 for the parent function. Now when we see them in other functions, the a is going to be out here. You want x minus h under here, and then your plus k is outside the radical. So in this case, 0, 0. Our x-intercept and our y-intercept, again, it's hitting at the origin. All of these parent functions tend to start at that origin. So that makes both our x and y-intercept 0, 0. What is the domain of the function? So you guys determined this when you told me what I wouldn't want to include in my chart. So we said there were certain numbers we could not plug into this function. Okay. We could not plug in negatives. So what is the domain of this function? What kind of x values can you plug in? Good. Only x's that are greater than or equal to 0. Okay? Or in other words, from 0 to infinity. So what about the range of the function? What are the y values that we're getting out? How would we describe them? Good. Y is also greater than or equal to 0. We don't get any negative values when we're calculating the square roots of the numbers that we've plugged in. Okay. So it looks the same there. What about increasing and decreasing intervals? So as you travel from left to right on this graph, first you have nothing. That's okay. Then you finally hit the graph, and from left to right you're going like this. What kind of behavior is that? Increasing. Does it ever turn around and start decreasing? No. So there is no decreasing interval. And how would you describe the increasing interval? Remember, you're telling the person the x values. You're saying from this x until this x, it's behaving of this idea of increasing. Good. Okay. So 0 to infinity. Because it's not a turning point? We'll see. I'll double check it. Because we've been having this debate. Yeah. Yeah, I know. Well, we're going to see. I'm going to check it, and I'll let you guys know tomorrow. So we were talking about this in the math office because there were some Algebra 2 students that had used a bracket all last year. Turning point, not turning point, whatever. And so if you look at a bunch of resources now, they only use parentheses. But the pre-calc book that we had used prior, like 8 years ago or something, did use brackets, even at a turning point, whatever. So I'll look up and I'll talk with our pre-calc teachers about notation that we're using for that part of it. Okay, so we'll come back tomorrow and adjust that if we need to. Is that good with everybody? Okay. All right, is it 1-to-1? Yes. Okay, it is a function. And then also notice the other way, horizontally, for every y value pick, there's only one x value that's lined up with it. Because this never goes completely horizontal. It just grows really slowly. Okay, so this one is 1-to-1. The axis of symmetry is not applicable here. Okay, so we don't have to worry about that. Minimum value, 0. So you can see by the range, all the y values were greater than or equal to 0, so 0 was the absolute minimum value that you reached. What about the maximum value? None. Is this okay for the idea of how our square root function is? Okay, so let's go to the example of this before we do the cube root function. Pick out the transformations and make sure we understand them, and then make sure we can adjust the table to get new points once a graph is transformed and fill this out. Okay? So here's our square root example. Okay? So for those of you that can't see it, the equation looks like this. All right, so before I can start picking out what's happening to x and what's happening to y and listing all the transformations, I need to make a small adjustment to my equation. Does anybody know how I should rewrite this equation just slightly so I can actually see what I need? Sophia? Good. So I can't take it all the way out, right? Most of you guys would go, you can't take the square root of a negative. But we can take the square root of this stuff in here. For example, if I plug in 1, this isn't actually negative underneath here, right? So I'm able to calculate the square root. So I'm going to rewrite the function with the negative factored out of just what's inside that radical. I'm not taking it all the way out the radical. I can't do that here. That doesn't make sense. But notice in every formula that we've studied, x minus h is a package. It doesn't say negative x minus h. It doesn't say 3x minus h. It has to just be x minus h. So to see what h is, you have to separate anything that's in front of x from your x minus h package. Okay? So then that makes this x, and how does that adjust the rest of what was in here? Good. Now it says minus 5 instead of plus 5. Okay. Which means what is value? Yeah, 5. Okay. So if you looked at it right here, though, you probably would have said negative 5, because usually it's the opposite of what you see, but that's because this was affecting the value. So you had to rewrite it with that separate. Then you see this and say, oh, this is x minus h. The h is positive 5. Okay. So my h is positive 5. My k is negative 3. And then I can't forget that I have this negative right here inside the radical. So that's causing a reflection. Every time we multiply by a negative, it causes a reflection. Okay. is this a reflection over the x-axis, means things are going to flip from up here to down here, meaning it's actually vertical? Or is this a reflection over the y-axis, where they change from left to right and it's horizontal? Good. It's flipping over the y, and this is horizontal. How I know that is because the negative is inside with x. It would change a positive x to a negative x, okay, on the x-axis. And so it would flip it over the y-axis. So this is a reflection over the y-axis. And then we have these two other values, the fact that h is 5 and k is negative 3. H is 5 is going to cause what transformation to our graph? What is this? Is it a reflection, a stretch, a compression, or a translation? So is it shifting the graph, flipping the graph, stretching or compressing the graph? Shifting the graph. So that's like a translation, okay? So this is translating our graph 5 units to the right. Okay? Then what is the k of negative 3 doing? Good. Okay. Another translation, because just shifting the graph, right? This time 3 units down. So on your quiz on Thursday, you do want to be able to list the transformations, because we did that now on quadratic homework and on cubic homework, and now we're talking about it here. So you want to pull out anything here, 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 and just list what's happening for each thing that you see. Okay? That should also tell you what to do with your chart. Okay? So the chart that we made for the parent function, we started with 0, we plugged in 1, 4, and 9, and we got out 0, 1, 2, and 3. So I either memorize this, or I quickly remake it using that parent function. Right? And then I know that I'm going to adjust those points using the 3 things that I wrote down, that there's this reflection, this translation, and this translation, but I have to know which one affects which coordinates. Okay. So what was inside of the function? What transformations were affecting x before you take the square root? Those things are going to affect x here in our chart. So when you look at the function, there was 2 different types of transformations happening underneath the radical, right? That means 2 things are going to be happening to our x coordinate right here. Okay? And the 2 things that were in there were this and this. And so they were this transformation and this transformation. So a reflection means multiply it by a negative. And then we're going to move it 5 units right. If you want to move to the right or up on the graph, you're adding. If you want to move to the left or down, you're subtracting. So to move 5 units right, we're then going to add 5. The other transformation, the k, was moving things down. It was outside of the function, so it was affecting the y column, the y values that were there. So that -3 is going to be happening here. All right, so I'm going to pause because they said, how do you know if it's going this way or this way? Remember, your vertex just got shifted to the new vertex. So this was the old vertex, the old starting point of the graph, right? And then it continued through these other points. That means this one is the new version of the vertex, and it continues through these points. So 5, -3 should be my stopping point, or my vertex point, and then I know it should travel through those other points that are on the graph. Okay, so don't lose track of the vertex point. If you're like, yeah, I got all the points and I got them on the graph, but I didn't know which way to draw it, the vertex point here should be your starting point. Okay? Any questions about how we came up with the numbers in the table? I just wrote them up here. I didn't write out the work, kind of on purpose, because I wanted you to see if you got the numbers, and I want you to ask me if you don't know how I got one of the numbers, so I can try to be more specific to what you need to hear and not just generalize everything. So we can all do this. We're all okay? Chart and graph. Okay, then go ahead and take a couple minutes and try to see if you can fill out all of this. You can leave the x-intercepts and y-intercepts blank for now because we're going to come back and do those with numerical values later. Okay, so we said you guys could leave x and y-intercepts blank for now. We're going to do that next week for all the different functions and review how to solve them, and you've been doing some of that in your weekly review. The domain here would be x values less than or equal to 5, or in other words, from negative infinity until 5. And then the range would be y values greater than or equal to negative 3, or from negative 3 to infinity. So we were discussing over there that this is constantly decreasing. I know you guys might want to say increasing because it's going like this, but you read it from left to right. So even though the arrow's going that way, that's not what we look at. We look at if we traveled along this curve from left to right, we would constantly be decreasing until this point, which is lined up on the x-axis with 5. And remember, we use the x values to describe these intervals. So there's a decreasing interval from negative infinity until 5. And I will get you your answer tomorrow. We'll either keep these parentheses or come back and change them this way. Okay? And then there is no increasing interval. It is still 1 to 1. The axis of symmetry is not applicable. Okay? Here you have a minimum value of negative 3 and no maximum value.